file, create new file, part. Okay, you go to the top plane, sketch, center rectangle from the origin. Okay, dimension, smart dimension. Well, this side is 500 by 400. Okay, feature, extrude to 300 mil, 300. Direction 1, actually direction 1, you see, might not change direction 1. Okay, remember also when we were making the cutout, we filleted our sketch of the bowl. We filleted this at 13 millimeter, at 30, sorry, this fillet is 30 mil, so you also need to do the same to the sink bowl. So fillet it at this point. You click on this constant size, fillet, and change this to 30 millimeter, and click on this edge. Sorry, not 300 but 30. Sorry about that. You click on this edge, you click on this edge, and finally this edge. I won't concentrate much on the bowl, and well, in my next video I will show you how to do a bowl, how to do a fabrication drawing for a bowl, whether you are doing it from whether you're doing the cutting from the CNC, the laser machine, or whether you are cutting it manually, the shearing and the grinders and all that. I will show you how to do it, because there are some notches that are very important for you to have a really nice bowl with some nice fillets. Click OK. There you go. Now what you will do is you go to shell. You shell it at parameter, give it at 1.5, because the material you're going to use, the thickness of the material is 1.5 millimeter. Click on the top, right click, OK. The ball is done, nice and good. Well, this is not so nice, like I've said. I'm not going to concentrate very much on the bowl. What this video was all about was the top and how to do the bending and all that. Therefore, I will leave it as it is. What I will do is create the hole for the drain, sketch, normal. I'll create a cutout at this center. A standard hole for the bottle trap and all that is 50 millimeter. You can do between, actually it is 50, because you're going to punch a die here to have a depression, and the die is 60 millimeter with an opening of 50, so that it may go. I'll create a small depression at that center where the I don't know how to call it, that cap of the bottle trap. It has to sit, it has to be sunken slightly. I will show you, don't worry about that, I will show you that in my next video. I will also try to pull up some photos of some of the things that we have fabricated before. So this extruded cut, link it to thickness, or you can do a blind on the other direction. Even 5 millimeter is okay. There you go. What's going on here? Wow, we can go to features and extrude and cut. No. Okay, I'm doing it the wrong way. So remember, my sketch was on this bottom, so it has to go on the opposite direction. There you go. There you go. You got your hole done, nice and good. I will save this as part 2, which is Paula. I like to this is how I do my drawings. I like to do assembly as I continue. Once I have part 1 and part 2, I do assembly, then I do the legs and everything. I also continue doing assembly, so I will right away go ahead and do assembly, and the first part to bring it in, insert is the top, and the other part is the bowl. Now when you're doing the assembly to this and you're doing the mating, this will be really simple, because all you need to do is go to the point on the fillet, click OK, and you go to the coincident part and try to get to that point at the center of the fillet, click OK, and your ball is nicely placed within the sink. So that the parameter is relationship is enough. There you have your sink, the bowl, and the center of the hole for the tap and the center of the hole for the drain. They are all centered completely. Now some people, when they are doing the bending for the bowls, they normally incorporate a say 10-15 millimeter bend, which will come to lie on top of, to be on the surface of the bottom of the sink for the purposes of a nice welding. But I find that it's cumbersome, waste of material, so I'll just do it direct, and my welding will be right on the edge between the bowl and the sink top. That's where I will do my welding all around. And like I said, we'll talk about the bowl in our next video. For now, it's just a startup and we want to keep it simple. There you go. There is your sink. Now what we are going to do is go to File, New, Part Drawing. Okay. And for commercial purposes, most things, some people like using legs of square tube 40 by 40 square, but after talking to so many people in the market, so many clients prefer round because of cleanliness and also safety purpose. So our sink will be having round legs of dia 38 millimeter. Dia 38 looks, it's a standard leg. Again, you don't want to put a very huge, let's say 50, 63 or 65 millimeter dia tube. So 38 is standard that we normally use a lot. So we go to the top plane, start a new sketch. Okay, circle, snap it to the center, click OK. Dia 38, sorry. Okay. And you can offset it if you want. If you want to leave it like a solid, it's okay. Nobody will see whether it's a solid or it's an open, but I like to keep it professional, so I will offset my circle by 1.5. Standard of thickness of this leg is 1.5. I will reverse the direction to inside, click OK, feature, extrude. Now the standard height of a sink is 860 millimeters, 850, 860. There will be a rubber grommet at the bottom of the leg, which is, say, an adjustable rubber grommet, which is 30 millimeter when it is fully adjusted, or thereabout that. So 860, we want our total height of the sink to be 860, so our leg, we are going to extrude it to 830. When we add the grommet, it will automatically become 860. God, don't for the purposes of assembly, just remember where your planes are at. I want to keep my plane at the bottom of the leg. I don't want to do mid plane, mid plane extruding. I just want to extrude a line so that my plane may be at the bottom. 830. This looks good. That's okay. Well, we save this as part 3. Part 3. Leg, and all the 4 legs are of the same size. Therefore, we don't need to draw all the 4. We just need one. Now, let us continue with it. Let us do the assembly. We insert the legs. That we may do the assembly for the leg. Place our leg there. We go to the sink top. The sink top, front plane. It is at the middle of the sink. We want to create a reference geometry, which is a plane. We define the plane. Remember, the plane is at the center of the sink, which is, remember, the overall size of the overall width of the sink is 600. So the plane is sitting at the center, which is 300, and you want your plane to come to this edge of the sink. You can go ahead and place a plane there. You see, which you will have some problems. So I would rather, instead of doing it like that, the calculations, let me go ahead and anyway, this looks, it's not bad, it looks good. So it will, it's not right. Let me do it the right way. Plane. Remember, I'm dealing with the front plane of the top of the sink top, not front plane of the entire assembly. So let me create a plane here. Now, if from at the center is at 300, and remember we have this 15mm and 15mm bend there, and I want this plane is the front plane and the front plane of the leg. I want to mate them so that my leg might be properly mated. Therefore, I will offset it from 300 minus 15. That should be 285, and also the leg is there 30. Let me pull a calculator real quick. Calculator. When these things were brought to us, we stopped thinking, why would I waste a lot of time doing math in my head while I have a calculator at my fingertips? So it's 300 minus 15. I don't know whether the 15mm, which is over here, will affect the center of the plane. I'm doing this 15 for the bend. Remember the bend that is under there, that comes to 285. 285. Then I take dia 38 divided by 2. That is 19mm. So my 285 minus 19mm, that is 266. Therefore, when I'm offsetting this plane, I will offset it to 266. It is something that we can always edit. Let us see whether it is really where we need it. We can only see that if once we have done the assembly. Therefore, I'll go ahead and accept that. Then I will click mate on that plane. The plane we've just created is over here, plane 1. Then I will pull down this menu and go to the leg of the sink, the leg we've just brought in. Pull down the menu. That is the front of the front of the sink. I want to mate it with the front of the leg. That's good. No. That is pretty much okay. Let us take the right plane. The right plane of the top of the head. The right plane. the sink top. Remember, our sink is 1500 divided by 2 should be 750 minus 15, that bend of this bend on this side, the 15 millimeter, that will give us 735 minus 19. That, what did I just do? I guess my mind is not fully alert. That is 1500 divided by 2 minus 15 minus 19. That should be at 760. So from the front plane of the sink top, right plane, sorry, of the sink top, I create reference geometry and plane at 7. Let's pull the calculator real quick. 716. You can flip the side if you want. 716. So this will be 716. Is it 716 or 766? 716 is good. 716. Let me flip the offset to the other side. That's okay. I've created a plane 2. Plane 2 is right here. That plane 2, I will mate it with the come on. I will mate it to the right plane of the leg. That's good enough. Then now I can mate this top of the leg to the highest point of the, where is it, to that face, that, and my leg is well mated to the top. No, see, it is touching this edge, wanted it to touch that edge and touch the other edge, the 15 millimeter, because what will happen when we are doing the welding, you don't want the weld to penetrate to the sink top. See the leg. Actually, let me undo. Did I just undo everything? It's still okay. Let's do the mating again. Mate that front plane to the front plane of the leg. It's mated. Then we do plane 2. We mate it with the right plane of the leg. So the top to the top. Yeah, that's about right. Then exit. Now we go to the front. Click this leg and this leg. Click OK. Yeah, see, that is right. Then you can go ahead and save it. Yes, save all. See that sink assembly. That's right. Now we need to do the bracing all around the sink. And since we used the diameter of the legs is 32, we have to use a diameter of 25. It's just a bracing, but diameter 25 will be sufficient, because when you notch at diameter 38, when you use bracing as diameter 38 and the legs are diameter 38, the welding don't look so neat. So you want to use diameter 25 tube so that it might fit right where you want it. Okay, so new file, part, click OK. Now the shorter bracing will be, remember I was saying this 600 minus 30, the 15 bend and the other bend, that should be about 570, and minus 38 because of 19 this side, 19 the other side, you get 532. So you go to the right plane is okay, click OK, circle, center, smart dimension 25 millimeter, that's okay. You offset it to 1.5, click the circle, reverse direction, that's okay. Or we extrude extrude it to 532, extrude blind to 532, that's okay. Okay, well, I should have used the other plane, but it's still okay. We save it as part number 4, and write it as short bracing. That's about right. And you go back to your assembly, insert component, short bracing, and the bracing will be going from here to here, therefore I can turn it like that. Now I go to the top of the leg. I create reference geometry, plane, offset it 200 millimeter, that's okay. You want there to be a clearance of 1200 from the ground, 200 millimeter, because of the cleaning under the sink and all that becomes easy. Therefore, plane number 3, I'm going to mate it. That is the top of the plane. I will mate it with the bracing top, bracing, short bracing top. That is okay. Then from there I take the right plane of the leg and the right plane of the bracing, the front plane of the bracing, met, that's okay. Click OK. Then I will take this part and mate it to this. Let's see whether it will come out right. No, is that right? Let me mate the right plane of the leg, of the bracing, to the front plane of the leg. Yeah, that looks about okay. See what I was telling you? Now, notching the bracing will be a bit easy, and the welding to look neat. That's right. Now, you can mirror component. extra components, bracing. Okay, go ahead and save. Now we want to put the bracing at the back. The bracing at the back, we go to new file, part. Okay, front plane, sketch, circle, dimension 25. Okay, offset 1.5. Click the circle, reverse dimension. That's okay. Extrude. Now we extrude. The sink is 1500 minus 30 minus 38 will give us 1470. So we extrude to 1470. That's okay. There we go. We save it as part 5. Part number 5. Long bracing. You can save it and give it a name which is appropriate for you. Go back to our assembly. Insert component, long bracing, rotate it. That's about right. Now I'm looking for the plane that will help us in sampling. Front plane, reference geometry, plane. I take it to 532. Okay, and flip offset. That's good. And that plane we met it with long bracing. The right plane. That's okay. Click OK first so that I may met components, bracing, top of that bracing, top of this. Okay, click OK. I might be required to create reference geometry, right plane, reference geometry, plane 532. Yeah, that is okay. Then that plane I mate it with looking for the long bracing. I made it with. Did we just make that? Yeah. So the plane that I created is unnecessary. is unnecessary because I want to this surface to be, so I'm looking to not the right plane, the front plane. I should mate it with which plane, yeah, I can mate this front plane of that short bracing and the front plane. There we go. Our bracing is done, but looks like we need to minus this 30, 38, 15, that is 30 minus 38. So let's see, long bracing, edit feature, 1470 minus 38. Some of these things you don't have to be taught by anybody, they just come automatically. Yeah, now it is fitting correctly. Now, putting a bracing on the front, if you put it at this level, the operator, when they are doing their dishes, it will always be a little bit, disturbing when it is at this level. Right here. So what we normally do, we have the front bracing coming right above here. You can do it at if you take the total height of the sink is 860 and the bowl is 300 minus 300, so the bracing can go up to 560 at a height of 560 from the base of the sink. So what I'm going to do is I will create a plane. The leg, front plane, reference geometry plane, and I take it to a height of, we said 570, right? 560 is good enough. 560. We have created plane number 6. So I will insert component, long bracing, turn it around. Sorry, it's about that. And I will take mate plane 6. I will mate it with that top plane. That is okay. Then I go to let's see which plane we are looking for. Yeah, the front plane of the leg. We mate it with is it the right plane of the new bracing that we've just brought in? Then we mate again the front plane of the leg of the bracing to which plane? To the right plane of the leg. There you are. And click OK. Yeah. See? Now, our sink is fully assembled and it is strong enough. The bracings are good, and when you look at the height of the bracing, it won't disturb anybody when they are doing their dishes. And your sink is good. So that is how we do a sink and the fabrication of it. I spoke about a few things about the fabrication. I'm not going to go ahead and do grommets. We'll do grommets on another project. Grommet is just a project. It's just a grommet. What you normally do is just insert the grommet here, and it's adjustable. You can adjust it to whatever height you want. So guys, that's about that. Well, next time we are going to do a bowl, fabrication of a bowl, how to design the fabrication drawing of a bowl. And you see, when you're doing a sink, say for a commercial kitchen, say the sink, whether it's a single bowl, a double bowl, a triple bowl, it's going to the meat prep area, or right about the wash up area, there is a lot of oil from either the meat, oil, fat from the meat or from the dishes. So you don't want it going down to the what do you call it, drainage system, because it's going to clog the system. So many a times we normally do a grease trap which sits right under the sink, a grease trap with strainer baskets, so all the dirt will be collected on the grease trap. Only the grease trap will allow only water to flow to the drain system. So you can remove the strainer baskets, put the dirt into waste bins and throw it to the garbage. The garbage collectors will take care of it. So you don't want all the dirt going to the drainage system. It will clog the system. So next project we will do a grease trap, a 2-stage grease trap together with the ball. So thank you so much for following my video. I wish you enjoy it. Next project will be coming soon. Don't forget to like and subscribe to my channel. We will be doing a lot of fabrication drawing for almost all commercial equipment that are used in a commercial kitchen. Thanks for your time. Have a lovely time. Thank you.